Hello dear student, this is Devansha from LG Institute of Engineering and Technology. We are learning the subject basic electrical engineering, and so far we learn about this topic is three-phase induction motor, rotating magnetic field, single phase induction motor, and in our today's session we are going to discuss about DC machines, and then we will discuss about alternators. So if we first talk about what are the DC machines, how it looks like. So here we can check here. There are two types of DC machines we are going to discuss. One is defined as a DC generator and DC motor. So here the DC generator converts mechanical energy into electrical energy. So here from this diagram you can see the prime movers will give the mechanical energy, and that mechanical energy is going to be converted into electrical energy by means of DC generator, right? Whereas in DC motor that will convert electrical energy into a mechanical energy. So here electrical energy is applied to the DC motor, and that will convert into a mechanical energy. So from this here prime movers we apply to generate a DC energy. Same way here the motor accept the energy in form of electrical form from DC source and convert it into a mechanical energy, its output. So one DC generator will take input as a mechanical and convert into a electrical. Same way DC motor will take input as a electrical and will convert into a mechanical. So from this, let us understand the basic principle behind this DC machine. So we here to operate DC machine as motor, here field winding is connected across a DC power source. So here this is the field winding which is connected across this DC power source, and armature winding connected to DC supply. So here you can consider this is a field winding where this will be the armature winding which is connected to the DC supply. So from this field windings acts as an electromagnet due to the DC field current flows through it and produces the magnetic flux in the air gap between two windings. So here this two magnet will produce the magnetic flux around it, and we are giving the rotation of this armature. By that way it will cut the magnetic flux, and once it will cut the magnetic flux, that will convert this mechanical energy into a electrical energy. This is the nothing but the Faraday's law of electromagnetic induction, where here the armature also carries the DC current. This armature which also carries the DC current, and it acts as a current carrying conductor placed in magnetic field produced by field winding. So from this you can check in this particular diagram. Now you assume this particular armature winding is continuously rotating in a clockwise direction. Once the current carrying this conductor is placed in a magnetic field, it experiences the force. So now this is the same story that we have discussed during the three-phase induction motor, the principle of rotating magnetic field. So ultimately here the force must be exerted once this conductor carrying the current. Once this force is exerted, that will convert into a kind of mechanical energy. So from this, in this case, the DC motor, the magnetic field is developed by field current. So here magnetic field is developed by the field current and the current flowing in this field winding. So here the armature winding is connected to external DC source. So here armature winding is connected to external DC source, and hence it plays the role of current carrying conductor placed in magnetic field. So due to this force exertion placed in a magnetic field, so it starts rotating, and armature also start rotating. So the direction of rotational depends on, so direction of this rotation depends on the direction of magnetic field produced by field winding and armature. So from this you can see the construction of the DC generator is same as the DC motor. From this figure you can check the front view of this DC machine, where the middle part we define as a armature, right, which is a slotted form, right. Around this there are the poles, and over the pole we wound a field winding. So here this is the field winding, inside there is a armature winding, these are the armature conductors. The outer part we define as a yoke, right. So this is what about the construction of DC generator. Now we will discuss the individual part of this construction. As first part we define as a yoke. So here the outer body of this DC machine we define as a yoke. So it acts as an outer cover of DC machine like this way. also known as a frame. It provides the protection to rotating and other parts of machine from the dirt, humidity, etc. of the environmental parameters. It is iron body which provides path for the flux, and it is made up of cast iron and silicon steel. Now the another part we define as a pole shoe and pole core. So from this particular parts we define as a pole. This is a pole shoe. This is a pole shoe, right? And the overall this portion we define as a pole core. So here it is electromagnet. So we are taking the individual part of this. This is a pole shoe. This field winding is bound over this winding is bound over this pole. We define as a field winding. This is a part of the pole. So here it is electromagnet. The field winding is bound over the poles. The poles produces the magnetic flux when field winding is excited, and pole shoe is extended part of the pole. Due to the enlarged area, more flux can pass through this air gap to the armature. So it is made up of cast iron and silicon steel. If we further discuss about the field winding, then this is this part of the field winding. Now this is the field winding which is wound over this pole. So here the coil wound around the pole core are defined as a field coil, and the field coil are connected in series with each other to form the field winding. So here current is passed through this field winding in a specific direction to a magnet to magnetize the pole. So here the alternate N and S pole are placed together. So if this is N, let us say this is S. If this is N, this is S. So here alternate poles are generated here. So because of this, once it will carry the the current, that means there is a production of magnetic flux inside this gap, right? So from this we can also learn about the armature winding. So from this armature winding, it is made up of the copper and placed in the armature slots. So this is the armature winding. It is placed in armature slots here, and this conductors are inner conduct and these conductors are inner connected to form armature winding. So when armature winding is rotated using the prime movers, it cuts magnetic lines and voltage gets induced in it. This is the electromagnetic induction law, and it is connected to external circuit through a commutator and brush. So this portion we define as a commutator, and it is connected here through the brush. So from this, let us discuss about the commutator, the job of commutator, and how it is shaped. So here the cylindrical drum mounted on a shaft along with the armature coil, right? So this part is the armature, this is the coil, and this small portion we define as a commutator, where if you enlarge this portion, it is looking like this way and this way, where there are the commutator lugs are available, the insulated copper segments is available. So this is a part of commutator, and it is in a cylindrical drum mounted form. It is made of a large number of wedge shaped segments of hard drawn copper which are insulated from each other by a thin layer of mica. Armature winding is stepped and connected in various segments. So what is the function of commutator? As you know, for a DC generator, it converts alternating EMF generated internally into a DC voltage. So in another way, it is a kind of rectifier that will convert generated EMF into a DC voltage. And another function is like for a DC motor, it helps to produce unidirectional torque, where the end of the commutator, there are brushes are connected. So here the commutator is rotating, but it is not possible to connect a load directly to it. So because of this, to collect the current from the commutator and apply to the external load, because of this we require the alignment of the brushes. So here brushes wears with the time, hence it would be replaced occasionally. So it's a kind of maintenance part. Now this all are nothing but the different parts of DC machines, and generators are usually classified according to the way in that fields are excited. So from that you can be able to find total two types of generators. One is separately excited generator and another one is a self-excited generator. Separately excited generator require the external force for his field magnet to energize. Same way in a self-excited generators is nothing but the field magnets are energized by the current produced by generator themselves. So from this you can see the complete tree of the types of DC DC generators here. So you can see the classification of DC generators, where this is a DC generator. There are two types of DC generator as we have discussed: a separately excited where it's required a separate DC source or external voltage, where in a self-excited is a within a force is generated. So from here the self-excited DC generators are in three form: series wound form, shunt wound form, and compound form, where you can check the circuits of series and shunt, where both armature and field are connected in series. Here armature and field both windings are connected in parallel. In a compound you will find the combination of this. So one is a long short and another one is a long shunt and another one is a short shunt. So from this see, this is nothing but a combination of series and parallel. This is nothing but the field winding and armature winding are connected in combination of series and parallel. This type of connections are there. So like they are classified into series, shunt, and compound form of self-excited DC generators. From this, now let us discuss the comparison of the separately excited DC generator, shunt DC generator, and series DC generator. So armature and field windings are not connected with each other in a separately excited generator, but in a shunt it is in a parallel, and in series it is in a series. So in field current is constant in separately excited generator as well as constant in a shunt DC generator, but not constant in a series. Same way the flux here is proportional to the current which is flowing in a shunt winding. Same way for the shunt case, but in series here the flux is proportional to both armature current as well as the shunt current or field current. Now here the resistance of field winding is very large for both the cases, for separately excited and shunt, but very small in a case of the series. If we talk about the different applications of these DC machines, then it is used in traction system, cranes, air compressors, vacuum cleaner, sewing machines, lathe machines, centrifugal pumps, fans, blowers, conveyors, lifts, weaving machines, and spinning machines. All these are applications of DC machines. Thank you, dear students. If you have find any difficulty, please write in a comment box.